Dear all, a very good day. In the present video, we are going to look at the production of X-ray and X-ray machine. Okay, so production of the X-ray is a topic related to how the X-rays are produced normally in the machines and what is the procedure that is usually required. Okay, so X-rays are generated when fast-moving electrons are suddenly deaccelerated by impinging on a target. That is, we have a very good electron beam in which the electrons have a very good velocity, and then these electrons are stopped suddenly, or their acceleration is stopped by hitting them, that is impinging them on a particular target. Now X-ray tube is basically a high vacuum diode when heated, diode with a heated cathode located opposite to the target anode. So we have a target which is normally the anode, and the complete assembly is in a form of a cathode ray tube, you can assume it. Okay, and it is completely in vacuum. Now at the cathode side there is a heater which is required for production of electron beam, and at the anode side there is a target on which the electron beam can hit. Now this diode is operated in the saturation mode with a fairly low cathode temperature, so that current through the tube does not depend on the applied anode voltage. Okay, so it forms a sort of a diode. Okay, it is operated in saturation mode, which has a fairly low cathode temperature, so that and cathode temperature is very low. Now this is because we do not want the effect of anode voltage on the current values. Okay, then the intensity of the X-ray depends on the current through the tube. Okay, so whatever the amount of current is flowing through the tube, on that depends how the X-rays are produced, or what is the intensity of X-rays that is being produced. The current can be varied by varying the heater current, which is in turn controls the cathode temperature. Okay, now current flows through the cathode. So current, if we are varying the heater current, then the cathode current can be varied. Okay, and so we can develop a control over the cathode temperature. Then the wavelength of X-rays depend upon the target material and the velocity of electrons hitting the target. Okay, so we know that wavelength is produced. Our wavelength of X-rays is very important because it is a very big factor which depends that how can X-rays penetrate particular material and which materials they cannot penetrate. So the wavelength of the X-rays is determined by the target material on which the X-rays or the electron beam is hitting. Okay, and the speed or the velocity with which these electron beams are hitting the target. Okay, this is a very rough diagram which is showing how the X-rays can be produced. Okay, here is a heater connector, and this is a cathode part with a heater, and then electron beams are being produced which hit a predefined anode. Okay, this is the target, and when these electron beams are hitting this target, X-rays are being produced in the particular direction. It is the cut of the anode also which diverts the X-rays in a particular direction. Now X-rays are produced in a specially constructed glass tube, which is basically having, so this X-rays are produced in a glass tube, and this is specially constructed glass tube. It has a few important parts, like part number 1, a source for the production of electrons. Okay, so there is an electron source, then energy source to accelerate the electrons. So electrons need to be accelerated at a very high energy to produce X-rays, so they can gain this high energy by current or voltage which has been applied. Then a free electron path, then there should be a mean free path between the anode and the cathode, between which electrons can flow. Now a means of focusing the electron beam, so there should be a means in which we can focus these electrons in the form of beam, so that it will hit the target. And finally we will have a device that will stop the electrons. A particular anode has been used here, depending upon its materials, wavelength will depend on the X-ray wavelength will depend on it. Now X-ray equipment for diagnostic purposes, that is for diagnosis of a particular operation, uses target voltage in the range of 30 to 100 kilovolt. Okay, so it uses a high voltage. It is a high voltage device using a voltage of 30 to 100 kilovolt. Okay, while the current is in several milliamperes. When the electron hits the target, only a small part of their energy is converted into the X-rays, and most of it is dissipated as heat. So it is not a very efficient device that can be input from him. So the target is made up of tungsten, which has a high melting point, and it does not melt easily when the electron beams hit that target. Now this is a very generalized structure of a X-ray machine. We can see there is an exposure switch and timer which controls how much time X-ray can be emitted and used, because X-rays are harmful to us. Now this is kilovolt selector, which sort of X-rays we want. Okay, this is voltage compensator circuit. Okay, then there is a filament supply and temperature control switch with a milliampere control here. Then there is high tension supply and a rectifier, which is converting this into or rectifying the AC current which we are getting at our home to the DC milliampere current. And this is the complete setup where the X-ray tube where the X-rays will be generated. Okay, so if we will look here, what are the important parts of an X-ray machine, we will see. The first part is for the producing high voltage, which is applied to the tube of the anode and cathode and comprises of a high voltage step up transformer followed by rectifiers. So we need a very high voltage in our X-ray machines, therefore we have step up transformers which keep on increasing the voltage. Okay, and thereafter these are rectified. Okay, the current through the tube follows a high tension path and is measured by an milliammeter meter. Then our KV selector switch facilitates changes in the voltage between exposure. Okay, so there is a KV switch which will tell how much time we need to how much voltage we need for the particular exposure. The voltage is measured with the help of kilovolt meter. The exposure switch controls the timer and does the duration of the application of kilovolt. The exposure switch is responsible for controlling the timer and also duration for which the kilovoltage is generated. Then there is the filament temperature that determines the tube current or milliampere. Okay, if we will look in the figure, then there is a filament temperature that determines the current of milliampere switch. Filament supply and temperature control is here. We should control the temperature here through the milliampere control switch. Okay, then finally the preferred method for providing a high voltage DC to anode X-ray tube is by the bridge rectifier using 4 volt. So we are using a rectifier here which is producing a direct current to this X-ray tube through which the X-ray will be generated. In this way the complete X-ray machine functions and it can be utilized for a particular application. Next we will see visualization of X-rays and its utilization in different applications. Okay, thank you.